So here, as you can see, I'm reinstalling my bottom end. I originally had a motor, a used motor that wasn't working quite good. It was it started to puke oil out of the breather. So I ended up buying a Predator 22 horse, the 670cc engine, and I'm so glad I did. The thing works awesome. So here I'm just reinstalling that, and then I gotta line up my pulleys next. And all I'm putting on it for sealant is just RTV, and I've been using this boat for I think 3 summers now, and I have not had a leak inside of it yet. On the back, you can kind of see it there. I have a little boat plug that I've put into it in case it does leak, because my original one did a little bit, and I had to drain it every now and then, but this one has not had a drop of water in it, so that worked great. Thought I'd talk about the belt system I've got here. I ordered these from Throttle Gear. This is a 1360, that's your millimeter belt length. The 8M is 8mm pitch. Here it just shows different tooth profile sizes. Mine's the 8mm curved tooth. So if you look down, it says curvilinear rounded tooth profile, also called high torque drive. And then here, this shows your horsepower rating. So the HTD, which is mine, 8 mil, we go over, we see 20, 30, 50, 85. Mine's the 30 millimeter width. If you go over a couple, it'll show your horsepower per inch. And that horsepower per inch is of width of your belt. So my belt's 30 millimeters wide, so 25 is 1 inch. So mine should just be over that 37.2 horsepower there. So here's my receipt that I ordered from Throttle Gear. This was the pulleys and the bushings. So important thing here to notice, your QD 40, that's your 40 teeth on your pulley, how many teeth there are on it. 8M is your 8 mil, you gotta match that with your belt. And then the 30 is your width in millimeters. Then you see my belt at the bottom. And then up top, the first one, that's your SH 3/4. So the SH is the bushing type, and you have to match that up with your pulley. So you'll see on number 2, it says SH bushing steel. You have to get the right bushing for that for your QD. So number 1, it says SH, your bushing type, and then 3/4 is your bore, what's going to be bolted onto your shaft. That's your shaft size. So this throttle here, this was my first one I put on. It's just a basic bike brake. But I realized after driving it, testing it, it doesn't give you the full range for the throttle for the motor. So after looking, I found that they actually make these with more of a range. And I got mine from Mud Buggy. They make these mud motors, and I was able to get a handle throttle right from them. Looks just like that, but it's got a longer range on it. Here I'm putting on a switch. One switch was going to be to operate the lights up front. The other switch was going to be for the electric clutch. I opted out on the electric clutch because I ended up getting the new motor, the Predator, and the shaft size was different. And I didn't want to have to buy a new electric clutch and have to remachine it again. And then, of course, I like something more reliable on the water, so an electric clutch, they can brake. So I just went with direct drive. after using this for, I don't know, maybe an hour, I noticed this Delrin polycolor style bushing really started to wear. What's happening, just the prop is just, this is acting as a thrust bearing, and I don't know if this engine is too powerful, too strong to handle just a simple Teflon or Delrin bushing, but I'm gonna try that out. And you can even see, like, on the backside just started to really eat away. So this Delrin, it has a lower melting temperature than Teflon. Teflon's around, I want to say 500 degrees Fahrenheit. These are like 175, if I'm remembering right. So I'm assuming that is why. Also, Teflon is like self-lubricating. So I made a Teflon one, and from a previous 15 horse engine, it had no problem with the Teflon. Like, it hardly showed any wear at all. So I'm hoping this has the better properties for a good good thrust bearing. And with that, I made up at the same time just some washers, and I'm hoping they are going to be a quick wear sign, or I just hope that these would wear before this, because I don't want to replace this all the time. Replacing these, I could make a handful of these in no time. So I'm hoping the friction between the Teflon and the stainless prop is going to hold. And since the coefficient of friction is between Teflon and Teflon so light, that I'm hoping that it's just going to ride against Teflon and Teflon instead. So I was also considering drilling in and pinning this, but I was like, I really don't want to get into that. So we're going to just try this for now. And I'm going to take some measurements, monitor the wear on it, take some pictures, and I'm sure it'll quickly tell me if it's going to last or if it's not. Just with me tightening this in, you can see that Teflon washer is sticking to the stainless prop, and it's just turning on the Teflon to Teflon. So that's a good sign. I hope that's gonna work. I also just did in the lathe, it's really hard to hold the Teflon, so when I was parting it off using the parting tool, I kind of machined a taper on it, but it's also kind of think that might be a good thing. Water will get in there and it might help lubricate it a little bit more. I don't know, but yeah, we're gonna find out. So after using this for a couple summers, I had that manual trim that it was just a threaded trim control, and I ended up getting this 4-inch linear actuator. It's just a 12 volt, 225 pound maximum lift on it, and so far it's been working great for the last 2 years. It was such a great upgrade because I was normally going through shallow to high speed, and with that you needed to change your trim, and this is great. As you're driving, you can watch your RPMs and trim up and down to get the best speed. So the first day I had this out on the water, I was getting problems with either cavitation or blowout. I couldn't get any speed with it. It was like, it sounded like it was cavitation. It was blowing water out, and all of a sudden it would bite and get a bite on the water, and then my whole front end of the boat would lift right up. But if I gave it any throttle, it would blow out again. And so I got a hold of the guy on YouTube who made a mud motor, and he told me to try I had a 9x6 on this. He told me to try a 10x8, and it absolutely fixed the problem. It's been working great ever since. So this is the basic end of this build series. I was going to leave you in suspense, but I will show a couple of sneak peek videos of the boat driving. But this summer I will be getting a better montage of the boat, get some drone shots, and get some better videos of the boat and how it works. So stay tuned, subscribe, and wait for the next video.